Okay, in this video, we want to come up with the formula of ionic compounds using the principle of charge neutrality, okay? Now, here I have a aluminum, which we know forms a +3 cation, and a sulfide that forms a -2 anion, okay? So one way of making sure that you have a neutral formula is say that the number of the positive cations is the charge of the negative, and the number of the negative is the charge of the positive. So if I took, since I have two of these, if I took 2 times +3, and I added that, since this charge is 3, I take 3 of these times -2, this equals 0. Okay? So simply speaking, if I take this number, bring it down here, and I take this number and bring it down here, I get a neutral compound. The problem with this is that this formula, Al2S3, these must be the lowest whole number ratios. Okay? Now, this looks fairly complicated, but we could make a matrix. Okay, and here I have a matrix. And in this matrix, I could have all the possible combinatorial possibilities. So here I have, so these are my cations, and I'll put my cations first here, and these are my anions. Okay? Now, if I look at this here, I have Kf. The charge of this is 1, the charge of this, so the formula is 1. Okay? Now I come over here. Since there's 2 of these, and the charge of this is 1, I have K2S. Okay? Now if I bring this down to here, so I have K3, and then this is a 1, I have P. So these are my neutral formulas. 3 times +1, when added to 1 times -3 equals 0. Now I come over here, okay? This is a 1, so I have 1 barium, and this is a 2, so I have 2 fluoride. So 1 times 2 plus 2 times -1 equals 0. Now we have to be careful here, because +2 and -2 are not the lowest whole number ratio. So if I blindly do that, I would say Ba, since the charge of fluorine is 2, I have 2 of these, times sulfur, and since the charge of the barium is 2, this is my formula, and this is neutral. 2 times +2 is 4, and 2 times -2 is -4. 4 minus 4 is 0, but these are not the lowest whole number ratio. I could divide both by 2, so the correct number is BAS. Okay? Now, I come over here to barium phosphide, and since there's 3 of these, I need 3 of the +2s, so it's BA3, and since this is a charge of +2, I need 2 of the -3s. So 3 times +2 plus 2 times -3 equals 0. This is a neutral formula. Now I come over here and I have Al, one of these, and then I have 3 of the fluorides. I come over here and I have Al2S3. Now I come over here, and I have the same problem I had with the barium sulfide. Okay, it would be Al3P3, but obviously that's not the lowest whole number ratio, so it would be ALP. Okay? Now I come over here to lead fluoride. Okay? 4 and 1, so I would have 1 of the leads for every 4 of the fluorides. 1 times +4, plus 4 times -1 is 0. Now if I look at the charge of the lead sulfide, 4 divides into 2. So an integer number of times, it should say 2 divides into 4, an integer number of times twice. So I could blindly do this, PB plus 4, S minus 2, and I would come up with PB2S 4, but this is not the lowest whole number ratio. The lowest whole number ratio is PBS2. I divide this by 2 and divide this by 2. So this becomes PBS2. It's not PB2S4. Okay? Oh, this is neutral. but it's not the lowest whole number ratio of cation to anion. Now I come over here, and now I hope you've seen how easy this is. It's Pb3, P4, because 3 times 4 plus 4 times minus 3 equals 0. Now I come over here, and I have Mn plus 5, so I have MnF5. I come over here, I have Mn2S5, okay? So 2 times plus 5 times minus 2 is 0. And 2 does not divide into 5, so this is correct. I come over here, and I have Mn3, P5. So 3 times 5 is 15. 5 times minus 3 is minus 15. 15 minus 15 is 0. So you can see how easy it is to come up with the formula of an ionic compound. And this covers all possibilities. Now, I understand you could have a plus 7 and more, but this is how easy it is.